Hey everyone, and welcome. Today we are diving deep into the hidden world inside every single tree. We're going to explore a really cool scientific breakthrough that could turn what's essentially a massive waste product into a key building block for a much greener future. I mean, just think about that for a second. It's a pretty wild thought, right? For every log that gets turned into paper or lumber, there's a huge amount of material just left over. For decades, most of that incredible potential has just been burned away. But what if we could finally unlock it? Well, the key to that lock, as it turns out, lies in solving a puzzle. And at the heart of that puzzle is a substance called lignin. Lignin is incredible stuff. Seriously. Right after cellulose, it is the most common natural polymer on the entire planet. Think of it as this super complex, rigid mesh that literally holds wood together. It's what gives a tree the strength to stand tall against the wind and weather. It's nature's superglue. And this is where we get to the great paradox of lignin. On one hand, we have this super abundant, totally renewable material with just massive potential. But, and it's a big but, its chemical structure is so complex and so stable that it has very low reactivity. It just doesn't like to bond with other things. So in big industrial processes like papermaking, it gets separated out and, well, it mostly just gets burned as a cheap fuel source. What a waste. So for a long, long time, the challenge for scientists has been pretty clear. How do we wake up this sleeping giant? How do we flip a switch and make it reactive? Okay, so the problem really comes down to these tiny molecular structures called methoxyl groups. The best way to think of them is like little plastic safety caps on an electrical plug. As long as those caps are on, lignin can't make the strong connections. It can't plug in and be useful in things like high-performance adhesives. Now, scientists have known how to pop these caps for a while, but the methods were, well, they were just not practical. We're talking about brute force here, cooking the lignin at ridiculously high temperatures and pressures for up to 6 hours at a time. It was inefficient, it was expensive, and it definitely wasn't very green. The real goal, the holy grail, was to find a much gentler way. And that brings us to the breakthrough. A team of researchers found a surprisingly mild, almost elegant way to give lignin a complete makeover. And get this, the new process is brilliantly simple. You just take your purified lignin, add a super common and inexpensive catalyst called sodium sulfite, and then you just heat it gently to 80 degrees Celsius. That's cooler than boiling water, and you only do it for an hour. That's it. It's that simple. So let's look at what's actually happening on a molecular level. That sodium sulfate catalyst, it acts like a specialized little tool. It latches onto those methoxyl safety caps we were talking about and just neatly pops them right off. But here's the clever part. It replaces them with these highly reactive hydroxyl groups, and suddenly, bam! Lignin has all these open ports just ready and waiting to form strong new bonds. And this isn't just a theory, they've got the receipts. This is an NMR scan, which is basically a way to see the chemical structure of something. Now look at that top scan, before the process. You see that big peak that's labeled 5? That's all those methoxy safety caps. Now look at the bottom scan, after their new process. See how much that peak is shrunk? That is the proof, right there. The caps are gone. And just how effective is it? The numbers really tell the story here. The concentration of those inactive groups plummeted by 43.5%. That is a huge chemical shift. And remember, they achieved it under incredibly mild, simple conditions. Okay, so that's the science, which is super cool. But you're probably wondering, what about the payoff? What can this newly activated supercharged lignin actually do in the real world? Well, the researchers put it to the test. They created a bio-based adhesive for plywood. As you can see in this chart, the resin using just standard lignin had a decent bonding strength. But look at the bar for the new activated lignin. The bond is significantly stronger. We're talking about a much more durable material. But hold on, because here's the other massive win. A lot of common wood adhesives release formaldehyde, which is a pretty nasty toxic gas. The resin they made with the new lignin, it absolutely slashed those harmful emissions. We're talking about a 62% reduction in formaldehyde emissions. That's huge. It doesn't just make the material stronger and makes it substantially safer for the people who make these products and for the homes they end up in. Honestly, the researchers themselves summed it up perfectly. They developed a method that is efficient, environmentally friendly, and cost-effective. That's the trifecta. That's what you need to take a brilliant idea from the lab and turn it into a real-world, large-scale industrial solution. So let's just zoom out for a second and look at the really big picture here. Why does a breakthrough like this matter so much? It matters because it's a potential game changer. It takes a massive industrial waste stream, lignin, and turns it into a high-value resource. It helps us create better, stronger products while getting us away from our dependence on petroleum-based chemicals. It makes those products safer for all of us. And it does all of this with an energy-efficient process that's totally ready to scale up.
It really leaves us with a powerful final thought, doesn't it? By unlocking the chemistry that's been hidden in nature all along, we can actually start to see a future where the very things we once threw away could become the essential building blocks of a more sustainable world. Thanks for joining me on this one.